Alright, so this video is on finding a solution to a system of equations by graphing. Okay, so a system of equations means I have more than one equation. Okay, and I'm looking for the solution. A solution is where the two meet. Okay, they can either meet in one place, they can meet in infinite places, meaning they're on top of each other, they're the same line, and that's called coinciding. Or they can have no solution, and that means they're parallel because they never meet. Okay, so the way we're going to have to do this is go ahead and graph each equation. So I'm going to first solve for y for each of these equations. So y equals negative x plus 6. So this is 0. So negative y equals negative x, or positive y would equal positive x. Okay, so now I need some solutions for each one so that I can graph them. X, x, y. Alright, so I'm going to use my good old 0, 1, and 2, 0, 1, and 2 for each one. Alright, so I'm plugging in 0, so negative 0 is just 0. So 0 plus 6 is 6. Alright, I'm plugging in 1, but there's a negative sign in front of it, so it's negative 1 plus 6 is 5. And I'm plugging in 2, but don't forget that negative, so it ends up being 4. Alright, next one. Well, if I plug in 0 for x, I get 0 for y. So are you noticing a pattern here? Whatever x is, y is. Pretty easy to tell. Alright, so let's go ahead and graph these. So graph the first one, 0, 6. 1, 2, 3, 4, 5, 6. 1, 5, 2, 4. Alright, so on these ones, it's even more important that your line is as straight as you can be through all these points, because that's going to help you find that point that the two of them share. Alright, graph the other one, 0, 0, 1, 1, 2, 2. You can start seeing a pattern here of where it probably is going to meet. Alright, so since I'm doing this by hand, it's hard to get exactly, but it seems pretty clear that they're meeting right there, which appears to be 3, 3. So the way you can tell for sure if it's 3, 3 is go ahead and plug 3 in to both of them. So obviously this one, 3, 3 is a solution because the x's and the y's are the same as each other. This one I plug in 3, so it'd be a negative 3 plus 6, and hey, I get 3 for that too. So 3, 3 is a solution for both of them. So these two intersect at 3, 3. All right, so let's look at another example. So here's another one. There's another one. Give ourselves a little room. There we go. All right, so first, again, solve for y. So plus negative x plus negative x. This one, y equals negative x plus 5. Alright, this one, plus negative 3x plus negative 3x. 3y equals negative 3x plus 15. Get rid of this 3, but don't forget I need to distribute it over here. So y equals, this would be a negative x plus 5. Alright, so right away, what do you notice? I solved them both for y. What did I get? I got the exact same equation, okay? That means they're going to end up being the same line, right? It doesn't matter what I plug in. It's going to be the same thing. It's the exact same thing twice, right? I plug in 0, 1, and 2. I get 0, 5. Plug in 1. I get 4. And I plug in 2. I get 3. It's going to be the exact same thing because it's the exact same equation. Right? Plug in 0, I get 5. Plug in 1, I get 4. Plug in 2, I get 3. So when I graph these, all the points are the same. 1, 2, 3, 4, 5. 1, 4, 2, 3. So both of these are this line. So that means they're intersecting constantly. Every single one of these points is a solution. So that's what's called coincide. These two equations coincide. They're the exact same equation. The way I remember that is it's kind of like coincidence. Hey, what a coincidence. These two equations are the same thing. Okay? So we've had our intersect, we've had our coincide. So let's look at one more. Here's our next one. Go ahead and solve for y. Negative y equals negative x plus negative 3. So that means positive y would be equal positive x plus positive 3. Next one. Negative y equals negative x plus 2. So positive y equals positive x plus negative 2. Alright, gotta do our table. Do 0, 1, and 2. 0 plus 3 is 3. 1 plus 3 is 4. And 2 plus 3 is 5. So 0, 3, 1, 4, 2, 5. Next one. Again, use my 0, 1, and 2. 0 plus negative 2 is negative 2. 1 plus negative 2 is negative 1. Oops, 1. And 2 plus negative 2 is 0. Alright, so 0, negative 2, 1, negative 1, 2, 0. Hey, what do we notice about these two? Connect these dots. So is there a solution that they share? No, okay? These two, and you can notice it's the exact same line. It's just moved up 1, 2, 3, 4, 5 spaces, right? This is 5 higher, this is 5 higher, this is 5 higher. So they're the same distance from each other in between each of their common points, right? You see how they're the same distance? So that means these two lines are parallel, which means there's going to be no solution. They're never going to meet, so they won't ever share a common solution. So those are our three options of what can happen. They can intersect, which is normally what happens most often, okay? And there's a solution, so there's our solution. Okay? They can coincide, which means they end up being the same equation. And you'll notice that pretty quickly, because when you solve for y, you'll get the same thing for both of them. You don't have to do the table out for both of them. You can just graph one of them, obviously, because it's the same thing, but I was just making a point, so they can coincide. And the last option is they can be parallel, okay? So the way you know for sure they're parallel, because sometimes they can look like they're not parallel, or sorry, they can look like they're parallel, but eventually meet, is that you notice that they're exactly 5 spaces apart, each one. So that's why it's a good idea to pick the same numbers if you can for each equation. And if they're parallel, that means they have no solution because they're never going to meet. So that's it. That's finding a solution to a system of equations by graphing.